Welcome back, everyone. In the last video, we started talking about load balancers. We learned how load balancers essentially manage the amount of traffic that each web server receives from the numerous number of browser clients that are making requests to our system. In this video, we're going to talk a little bit more about what else load balancers can do. Now, here I'm going to show you an example where we still have our three clones, web server A, B, and C. But on the left here, I'm reducing the example down to 4 different user clients. The reason for this is because we need to talk about session persistence. What is session persistence? You can think about applications where you need to maintain a consistent connection between your client and your server because you're constantly requesting information. When we think about our Facebook example with the news feed, if you're continually scrolling, or if you have Facebook Messenger open and you're constantly chatting with a different user, in that case, what's happening is that you're constantly making requests to the web server in order to receive new data that is specific to the session you have open. Think about many applications that you use today. You have a persistent session where there's information the web server needs to know about what you're doing so that it can give you up-to-date information relative to your session. This means that this communication between your client and your server has to be consistent, meaning that you cannot jump between multiple servers and one client. The reason for this is because that server is the one that is aware of what it has given the session so far. So this means that you need to maintain some type of persistent connection between a client and a web server. So here, let's take an example and see how the load balancer does this. So very similar to what we saw before, user 1 sends a request to the load balancer because the load balancer represents the entry point to our system. The load balancer, following round robin, will then be like, oh, of the servers I have, which one is the available one? Well, server A is the first one that's available in my list, so I'm going to establish the connection, and then now I'm going to lock it in. So now user 1 can continue to request things from this new server A connection it has. So it will send the request, which the load balancer will pass to server A, because that is now the connection between user 1 client and server A that the load balancer remembers. The load balancer is keeping track of that session persistence, meaning that the session between user 1 and server A is maintained, and the load balancer knows whenever it receives a request from user 1, it's going to forward it to server A because that's the established connection. Server A will then send that response back to the load balancer, and the load balancer will send that to user 1. And this connection continues to be maintained, so when user 2 comes in and says, hey, I'm trying to establish a connection, I want something, the load balancer goes round robin again. Oh, next available server, server B. It's balancing it the same way. It's just going in order. And now, just like we saw before, connection is established. When user 2 requests post, the load balancer knows, oh, this goes to server B. That's what I have stored in my memory. And now when server B sends back, hey, I've got these posts for user 2, the load balancer passes it on. Again, user 3 will do a request to the load balancer. Same thing, load balancer sees, according to my round robin, which is the next server. What's server C? So here now, we establish this connection. I'm keeping this locked in my memory. Now when user 3 requests post, the load balancer passes it to server C. Server C passes back the response, which the load balancer passes back to the correct client, user 3. And then finally with user 4, we send a connection request to the load balancer. Load balancer goes, oh, round robin, what's my next server? We went through C just now, so we're going to start all over again, back to web server A. Now, it's true that at this point, server A is retaining a connection between user 1 and itself. So here, server A might actually already be getting traffic. But again, the load balancer doesn't need to know that. All it knows is that, hey, I'm assuming that these servers do have capacity and that they are equal according to the round robin strategy. So just like before, this connection gets established. We then make that connection. And now when user 4 requests posts, it knows to pass it to server A, and then server A, when it passes back the response, the load balancer continues to pass it to the correct user. Now here, these connections are now maintained. So no matter how these requests continue to go, the load balancer knows to retain these sessions so that it's always passing the requests and the responses to the appropriate client. And this maintain connection is different from what we saw previously because, again, these servers have context of the sessions. This session persistence is not always necessary, but in certain applications that we need, where there does need to be session persistence, the load balancer is the one that can really help us retain this. Now, the actual strategies for this type of session persistence, we'll talk about later in the course when we talk more about load balancers. But for now, just understand this is another function the load balancer can do in a very common setting where we do need session persistence in our applications. So, as we discussed before, what happens if a server goes down? Let's say that we had these sessions and these different connections already maintained and established with our load balancer. What happens, the load balancer now knows that it does need to once again redistribute user 1 and user 4's connections. So here it will have to properly distribute it between server B and server C. Now, the thing here to remember is that in this context, what is happening here is that when the server goes down, the load balancer knows what the available servers are as resources. All it's trying to do is to actually route the traffic evenly. Whether or not the servers are being overwhelmed or not, and we need new servers, i.e. new clones being spun up or not, that's not always the load balancer's responsibility. Sometimes it is, sometimes it isn't. But the key thing to remember here is that at least in this example, we're not focused on that right now. All the load balancer needs to do is just distribute as best as it can the load. Now, for those of you that are curious, how is it that with session persistence, if server A went down, how does server B and server C, who are taking over user 1 and user 4 sessions, keep track of what the session's information was that server A was doing? So here is where there are different strategies of how you actually retain that session information. You can keep it on the client with user 1 and user 4 respectively having information that gets sent in the requests about what the session is about so far. And then server B and server C, when they take over, they'll have to spend some time computing to make sure that they catch up to what server A was doing so that they can accurately take over the session. This is going to happen regardless. There needs to be some additional time that server B and server C need to catch up to the session. That is inevitable. But where you store that information so that they can figure that out, you can do it on the client or you can do it on the load balancer. These are two different strategies. We'll go into them much deeper when we actually, again, talk about load balancers in a greater depth later. But for now, in case you're curious, that is something that does need to happen. If a server goes down and another server needs to take over a session, there will be additional computation time in order for these servers to catch up to what's happening. Now, the user experience is going to be worse because they're going to be waiting for these servers to figure it out. So all they're going to see is a delay. But this is, again, part of system design. We try and make our systems reliable, and also we want them to be robust. But in the end of the day, sometimes these things happen. Servers go down and the user gets a bad experience. But we are trying to minimize the amount that's happening. And that's really the core thing that we're trying to establish here, either with the load balancer or much of our system design that we're doing. So there you go. That's pretty much what we need to understand about load balancers at a high level. So now we can move on and look at the next piece in our diagram.